overwhelming. Okay, so this is the rest of yesterday's lesson. So the rest of 5.2. And then tomorrow we'll look at 5.3. And Thursday we'll look at 5.3 as well, I believe. Is what the plans are. So the rest of 5.2 is graphing polynomials, okay? To graph a polynomial function, you first plot points to determine the shape of the graph's middle portion. Then you use what you know about the end behavior to sketch the ends of the graph. Okay? So, we're going to first plot some points, then we're going to say, oh, let's look at this and decide what the end behavior is so that we know which direction it's facing and go. Okay, how do you think we plot some points? What do you think we do to plot points? Plug stuff in and get stuff out. I would suggest sticking with the standard -3, -2, -1, 0, 1, 2, 3 on all of your stuff. I would just suggest that. It might make your life a little easier. So we're going to plug and chop, okay? There is no easy way around this. You just have to do it that way. You don't have graphing calculators. Okay? So if I'm going to graph -x cubed plus x squared plus 3x minus 3, okay, I'm going to make a chart that says -3, -2, -1, 0, 1, 2, 3. My inputs and my outputs, okay? So I I can't talk. I should see a lot of input and output charts on your stuff tonight. When I plug -3 into this equation, I'm going to go ahead and just do it down here, and then I'll just erase everything. Okay, when I plug -3 in, what's -3 squared? That's easy. What's -3 cubed? -27, then times negative again, so 27. -3 squared, 9. 3 times -3, and -3. These cancel. 27 minus 3 is 24. Yeah? Then we'll come here and we'll erase this and we'll plug in -2. -2 cubed, -8, -8, and negative is +8. -2 squared is 4. 3 and -2 is -6. Oh, and -3. So 3. Get 3 out, right? Okay. Then we're going to come here and we're going to plug -1 in. See how fun this is? Okay, -1 cubed is -1 times negative is 1. -1 squared is 1. 3 times -1 is -3 and -3. So -6, 5, 4, -4, right? Okay. Then we're going to come and plug 0 in. 0 is our favorite. So this is 0 plus 0 plus 0 minus 3.
Do you have to show you what we do? Or can you show me?
No, you can just write it. Cadence like this. And then plug in 1, 1. When I plug in 1, I get -1 plus 1 plus 3 minus 3. So 0. Then I can plug in 2. Okay. 2 cubed is 8. -8 plus 4 plus 6 minus 3. -1, right?
Mm-hmm.
I know, I gotta think. And plug in a 3. So 3 cubed is 27, so -27 now, plus 9, plus 9, minus 3, right? You said 6?
Wait.
No.
No, -12.
Yes. -12. So we have some numbers to plug in, okay? Now, my leading coefficient is negative or positive. What's my leading coefficient? Negative. My power is odd or even. So what does that look like graph-wise? It's a backwards in, yeah, it's a backwards type in looking thing. So when I go to graph this, okay, 1, 2, 3, 1, 2, 3, we're gonna say negative 3, 24. We're gonna pretend that I'm doing this right. Negative 2, 3, negative 1, negative 4, 0, negative 3, 1, 0, 2, negative 1, and 3, negative 12. And would that make sense that it would go like that? That's what we're doing. Okay, look at the next one. The next one, what do you know about that one right away? X to the fourth minus x cubed minus 4x squared plus 4. What way is my graph facing? And what type of shape is it? A W? Up and down, or like, oh, it's a W, so it's right there. Okay. It looks like a W. And we know that because the leading coefficient is 1, or is positive, and the power is even. We do the same thing, we plug numbers in. So we're gonna have to the fourth minus cubed 4 squared plus 4. So negative 3, start there. What's negative 3 to the fourth? What? 81. Negative 3 cubed is negative 27, and then times a negative is positive 27. Negative 3 squared is 9. 9 times negative 4, and then plus 4. So 81 plus 27 minus 36 plus 4 gives me 76. Your graphs are going to be big. Yeah. So count by something large on your, yes, large on your. Okay, negative 2 to the fourth is what? Negative 2 cubed is 8, so negative 8. Negative 2 squared is 4, 4 and 4 is 16, and 4. So negative 8 or negative 4. Wait, you're saying this is positive 8? Oh, you're right, you're right, you're right. So 4 and 8 is 12, right? Plug in a negative 1. This becomes 1. This becomes 1. This becomes negative 4 and 4. So boom, boom, so I get 2. We haven't really curved yet, I don't think, right? So that's gonna be interesting. 0, 0, 0 would give me 4, yes? And we plug in ones, ones, ones. 1 minus 1 minus 4 plus 4. So 0. Plug in 2, 2, 2. 2 to the fourth we said was 36? 16. You're right. It was whatever. Okay. 2 cubed is 8, so negative 8. 4, negative 16, and 4, yeah? Negative 4. Then we plug in 3. 3 to the fourth was what? 81. I think you're right. Negative 27. 3 squared is 9. 9 and negative 4 is negative 36, right? And then plus 4. 81 minus 27 minus 36 plus 4, 22. Okay, so then from there, we have to make a graph. negative 3 is way up at 76, negative 2 is up at like 12, negative 1 is at like 2, and 0 is at 4, right? Then 1 is at 0, and then 2 is at negative 4, and then 3 is at like 22. So W-like shape. Yep. Okay. One last thing. We'll do a word problem. The energy E in foot pounds in each square foot of a wave is given by the model E equals 0.029 s to the fourth, where s is the wind speed in knots. Graph the model, use the graph to estimate the wind speed needed to generate a wind with 1,000 foot-pound of energy per square foot. How would we graph this? What would you do? What would you do to graph this? What do you mean put it in the equation first? They gave us an equation. Yeah, just plug stuff in for s. So if I were you, I'd plug in like 10, 20, 30, 40, whatever. Then they want to know at the end how much is needed to generate a wave with 1,000 foot-pounds of energy per square foot. How would you figure that out? No. 1,000 would be your, it would be your E, okay? So here's what you have to do on that. If 1,000 is your E, that means you have 1,000 equals, and then what was it, 0.0029 s to the fourth. How do you get rid of a fourth?
Well, you're right.
Yeah, you have to take the fourth root of something. How do you do the fourth root on your graph, on your calculator? Anybody have an idea?
You just keep the one, click x squared times.
Let me show you.
You keep the one with the x squared, that's before.
Yeah, Eddie, you are correct. So if you just take and press 4 and hit the one that has the x with it, it's above your caret, it will change it to the fourth root. So then you just put that in your calculator, the fourth root of whatever. Okay, mine's a little different because I have a special calculator, so. The fourth root of, we want to take 1,000, right? And you would get something like this, 5.6 if I round to one decimal. And then I have this. How do I solve from there? Divide. And what s would equal? Like 1939.1 is what I get, okay? If your answer 19.39 in the book here, it has us graph it and it says it comes out to about 24 is where E would be, or where S would be. The wind speed 24. So if I did it that way, I can figure it out. Okay. That's what you're looking at doing tonight, graphing. That's why I wanted to do it separate, because it just takes so much time. Plugging in and going.